Good morning, Angela.
Good morning.
I think I'm going to leave my camera off today. I had a session last week. She was from Denmark, but my computer completely crashed
Oh no.
right in the middle of the session, and it wouldn't reboot, had to repair itself, took a few hours. So I don't know if it had anything to do with the fact she was calling from Denmark. I don't know why that would affect anything, but
Yeah. Did
just
you ever get to finish your session with her?
well, no, my computer did fix itself and reboot fine, and I did do the session Monday morning instead of last Friday morning. So yeah, and we did finish it, but I made sure
Good.
that I didn't use the camera and I made sure I had nothing else running. So I think what probably happened is it just GoToMeeting used up all the resources and didn't even have time to warn me.
Oh no.
The dreaded blue screen. The blue screen that you don't ever want to see. Here, let me. Okay. Did we do number 6? I don't think we did. I think we did number 5, the number of years until Katie will be 8 times as old as she is now.
Yeah, no, we did not do number 6.
Okay. Normally I mark it down. Okay.
Okay, and quantity A would be larger. Oh wait. Yes, yeah, what?
Okay, let's have a look here. Or it could be drawn like this. So now what do you think? Still think quantity A is larger?
Well, yeah, I was actually doing, well, going by, calculating it.
Okay.
So,
The problem is that for the isosceles, I'm sorry, I drew this wrong. My mistake. I didn't see the right triangle. I thought it was an isosceles triangle that could have a variable base. In other words, that's why I drew this picture and this picture. And I'm not sure. I was about to try some numbers to see whether this was a bigger area than this. But since it has to be a right isosceles triangle, so the area of this is 18, and the area of this, and you figured out this height and calculated it?
yes, yeah, I did the area of the equilateral triangle the formula gave me, side squared, root 3.
Very good. We haven't encountered that formula in a while.
Right.
And it was, what is it, root 3 over 4
Yes.
times s squared?
Yes.
All right, good. You're way ahead of me on that problem then. Can you read that?
Yes.
A little fuzzy. I'm labeling these with A, B, C, D so that we can think about them and differentiate them.
Okay, now it looks like, well, let's see, the probability that the product of two could be A and C, A and D, B and C, and B and D.
Okay.
So 4. So quantity A would be larger.
Really? Because instinctively, here's the way I was thinking through this problem. As I said, I haven't viewed these problems before, so I'm going through them the first time also.
Okay.
My first thought was, well, we could certainly lay it all out and do it the hard way, the long way. That's easy enough to do. And as long as you do it without a mistake, that'll give you the right answer. But is there a shortcut? Well, we have the equal amount of negative ones as we have ones. So the combinations of everything is going to be pretty much the same. There's only one hitch, is that when you have -1 times -1, you come up with a +1.
Right.
Whereas when you have the 1 times the 1, you still come up with a +1. So to me, instinctively, it seems like there's more ways to come up with 1 than there is -1. Let's just see. Let's do it the easy way here. We can do it that way. We can do it that way. We can do it that way. We can also do it this way and this way, and finally we can do it this way. Okay, this way is a 1. This way is a -1. This way is a -1. Interesting. There's twice as many -1s. This way is a -1. This is a -1, and this is a 1. You're right. -1 rules. Or does it? Yeah, we got 1, 2, 3, 4 versus 2. Huh. Okay, let me just see if I have the answers on this one. For 7. This is 7A. Very good. You did it this way here, basically, correct?
Yes. Yeah.
Yeah, and we also didn't really need to consider the reverse. In other words, if B was first and A was second, all of these reverses are going to give you the same number as this. So if this was 4-2, even if we include the reverse situations where order matters, it's still going to be 4-2. All right. Uh-oh. Let's see. This is the next page. Excuse me.
Bless you. Bless you.
Come in 3.
Bless you.
Ah, thank you. So number 8. So what was the sales price of the DVD player?
$92.
So you go to the cash register, you rack it up, and she charges you 8% tax.
So it would be $99.36.
Right. You can almost tell that by just looking at it. There's this principle that if you lose 10%, you have to make more than 10% back to break even. Look at, if I take $100 and lose 90%, goes all the way down to $10. Well, if I make 90% back on $10, I only get back to $19. So you have to make a lot more back than you do loss percentage-wise. So immediately we know that if we knock off 8% and then add 8% to the new price, we're not going to get back to 100, but it's going to be very close.
Okay.
If you were really pressed for time on this, I would look and pick this automatically.
Okay.
Without doing the math. But of course on this one, it's not that hard to do the math. Wow, where did these problems come from?
Okay, so let's see, some of the lengths of so there are 12 edges.
I misread it again. Excuse me, my mind's not thinking real well this morning. I'm not reading the problems. I thought the side length of each cube is 3 feet. What's the volume? But this is a lot harder. So what's the edge length?
Let's see, what would that be, 4 inches?
Leave it in feet, because you don't want to have to go back and convert back to cubic feet. In other words,
Okay.
everything here is in feet. So what part of a foot is the side length?
It would be 1/3 foot. Am I saying that correctly?
Let's see, we have 3 feet divided by how many edges?
12.
So that's 1/4 of a foot.
Yeah, 1/4 of a foot.
Now what's the volume of the cube?
And the volume would be 1/64.
Correct.
Okay, 52 minutes.
Does that make sense? 14:25. Yes, it does. Okay. I hadn't done it yet. What's your...
What I did was I took 24 minus 10 plus 1 page.
Okay, so that's 15 pages per 30 minutes.
Right, so 2 minutes per page.
Okay, so 1 page per 2 minutes.
And then we went from, 50 minus 20, wait, did I do that correctly?
Yes.
Yeah, 50 minus 25 plus 1
So 26 pages
at 2 minutes.
per page, 52 minutes. Very good. Let's just double check our answers. It's 10. They like these counting problems. They particularly like these, how many rows are between 10 and 25, which is essentially what that question was.
Right.
Okay. Number 11.
You know what? I'm not even sure.
Let's count through this. This is a little bit of a strange problem. We haven't seen much like this. Let's look at, in order for this to be positive, it has to be plus plus or minus minus. Right?
Yes.
Okay. Let's count how many m's will give us a plus plus and how many m's will give us a minus minus. M has to be less than or equal to 100. It has to be a positive integer. So to get this situation, how many do we have? How many m's will produce a plus plus?
I'm not sure I understand. Am I supposed to be plugging in like
No, let's look at all the m's less than or equal to 100. Well, if we looked at the number 2, this is minus, so that actually works. But if we look at the number 40, this one would be plus, this one would be minus, so their product would not be positive. So let's look at what produces plus plus. Well, what produces plus plus is any m greater than 46. So 46 through 100, which is 55 numbers. So there's 55 m's that will produce plus plus.
Okay.
And how many m's will produce minus minus? I think only 1, 2, 3, and 4. Notice that when m is 1, 2, 3, or 4, this side is minus and this side is minus. As soon as m gets to be 5, this side is 0, their product is 0. When m is 6, this is plus, this is minus. So I count 4 additional, so 59 is what I think it is. Let's see if that's one of the choices. It is.
I would never have gotten this problem.
Well, it's probably because it was a bit new and you weren't quite sure what they were saying. We hadn't had anything like that in any of those preliminaries. Let me just check the answer key here. What did I say? 59, so it should be D for 11. Yeah. What are those other two letters they stick? A and G. D is the answer. A, G, what would that mean? Can't even imagine. All right, let's try 12.
See, on this one I think back solving.
Well, there is a very important principle at play here.
Okay.
Well, let's talk about it. Let me explain the principle to you and then see if you would rather apply that principle rather than back solving it. If the radius of this circle, all circles are similar, okay? If the radius of that circle is 2 and the radius of this circle is 6, their radiuses are in a 3-to-1 proportion. What are their areas in?
Also 3-to-1?
No, that's
No?
the key thing. So when you go from 1 dimension, which is a radius, to 2 dimensions, which is an area, the area factor goes to 9-to-1. It goes to the square of the linear factor. In other words, instead of a 3-to-1 ratio, the areas actually have a 9-to-1 ratio. Let's figure it out. This is 4 pi. This is 36 pi. 9-to-1. If we were to go to a sphere, I can't draw a sphere, but that's my sphere, and that had a radius of 6, the ratio between this little sphere with a radius of 2 and this big sphere with a radius of 6 is 3-to-1 cubed. In other words, their linear ratio is 3-to-1, but their volume ratio is 3 cubed to 1, or 27 to 1.
Okay.
Okay? It's kind of like why you can fit 144 cubic inches into a cubic foot. Same thing. In other words, it doesn't have to be circles. It can also be a square or a rectangle for that matter. But if I take 2 squares and I make this side 2 and this side 3, what is the ratio of their areas?
I guess I don't understand.
Okay, let's take their linear ratio.
Okay.
That's 3-to-2. Their area ratio is 3/2 squared, and their volume ratio is 3/2 cubed.
Cubed. Okay.
Notice that the area of this square is 4, the area of this square is 9, so we can readily see that their area relationship is now 9-to-4, not 3-to-2. So how we progress from linear to area to volume is always this way.
Okay.
It doesn't matter whether we're circles, squares, polygons. If you're going from 1 dimension to 2 dimensions, it needs to be squared. Okay, so in this particular problem, it's circular, and this is, 20. This one is 30, and she says she wants to use the tiles that are the same size. Well, we're talking area. So how much more area does this circle have over this circle? What is their ratio?
9-to-4.
Okay, which is which number here?
C.
What is 9/4?
It's going to be C. No? No, A.
9/4 is 2.25.
2.5.
Okay. If they wanted to be particularly difficult, they might go in the other direction. They might say, Well, we have an area ratio of 25 to 9. What is the ratio of the radiuses? So let me give you that problem. Here's my area. This is 25. Here's this area. This is 9. We'll make it, no, we'll just leave it like that. What is the ratio of their radiuses or their circumferences? Because the circumference is a linear dimension. So the ratio of their circumferences, oddly enough, is the same ratio of their radiuses. Because you get circumference by doing 2 pi r, you don't square r. So if this circle has an area of 25 and this circle has an area of 9, what is the ratio of their diameters or their radiuses or their circumferences?
Well, the radius would be 5 to 3.
There you go. That's all you need.
Okay.
That was the question. What is the ratio of the radiuses? Also be the ratio of the diameters, also be the ratio of the circumferences.
Okay.
All right.
I'm not sure.
What are the various methods we could use to solve it? Can we back solve it?
Yeah.
Okay, let's do that. Always, whenever you can't figure out how to proceed with a problem, always think back solving and see if that would work. And in this case, it's actually going to work pretty easily. Could there be 1,675 students? Why am I starting with the lowest one? Well, because I can see that if it's certainly not one of these numbers. Well, no, I'm not sure about, no. I better not say that. Let's use our regular back solving method, which is to start with the second lowest. Now what are we going to do?
I'm not sure.
Okay. Remember that we are postulating that there are 1,775 students in the high school. And they're saying that every year between 70 and 85% go to the homecoming rally, and 1,435 students attended the rally. So let's take the student enrollment, which we're speculating on, multiply it by 70%, what do you get?
1,242.
I'm sorry, 1,242?
Yes.
And what do you get when you multiply it by 85%?
1,508.
Could
And I'm
that,
not actually rounding up.
so could that be a possible number of students enrolled?
Yes.
Yes, because 1,435 attended the rally. 1,435 is between these two numbers. Now, if this number would have been lower than 1,435, let's say it came out to be 1,408, we would know that we need to go higher, right?
Yes.
100% sure. So then we'd try 1975 and we would know our answer. So this actually is a classic textbook case of back solving. It's not only can you solve it by back solving, but you can guarantee you'll get the solution in 2 attempts. And again, they reward those people that tried B as their first attempt. I don't know if that's accidental or not. It might be, but I'm not convinced it is accidental. Maybe it's just that Barron's rewarded. I don't know that you can necessarily make the same assumption about the people who put out the test, that they would reward that. Okay. Yeah, let's skip these, and that's actually legible enough to read, but since we have a limited amount of time, let's go to more test questions, and we can come back to that later if we have time. Let's see. Yeah, there are some more questions here. That one is for 14 through 16, so let's go to 17. Oops, hold on.
Okay, I'm coming up with the answer of 66, but I'm not sure if I did it correctly. I did 40 envelopes per hour is, 40 divided by 60.
Okay.
And then I multiplied 99 minutes by that.
Okay. That's a good way to do it.
Okay.
That's the perfect, I think that's as straightforward as you can get. It also is a ratio problem. Let's just look at it as a ratio problem.
Okay.
We could say 40 envelopes is to 1 hour as X envelopes is to, let's make that 60 minutes to 99 minutes. And there's our ratio.
Okay.
And X will come out to be 2/3 times 99, which is 66. So, oops, hold on. Trying to get it so I'm not covering it up. There.
Well, it looks like, let's see, indicate also. Well, the slices of pizza on the lower end would be $1.50 and $1.50, and then $1 for a small soda, so $4 could be the lowest end.
Okay.
Oh, 2 sodas, so $5. Oh wait, did I do that right? Yeah, 3, 4, $5 can be the lowest end, so $5 works.
And they want all answers. Okay, so basically we're going to back solve this, right?
Right, and then
So 5 works.
And then on the higher end, we could have 2 pieces of pizza for $4, and then $3.50 for the sodas. Is that right?
In order to figure out whether you can have a $5.25 charge, is there any way we can take our original lowest possible, which was 2 cheap pizzas and 2 cheap sodas, and increase it by 25%.
I didn't understand that.
Okay. If we took our lowest, this is the cheapest meal we can get.
Right.
Can we get a meal for just 25 cents more if we look at the prices of everything?
Oh, no.
No, we can't. So we can rule out $5.25. So $5.25 is a no-go for sure. Can we get a meal that's precisely $1 more?
Only if we added another soda.
How about if we get 2 expensive pieces of pizza instead of the 2 cheap kind? Then it's exactly $1 more than our $5 one.
Got it, yes.
So $6 works. Can we get $6.25?
No.
Well, if we go back to our cheapest order and substitute a $1.75 drink for a $1 drink, oh, that's $5.75. So that would be $5.75. But then if we substitute a $2 pizza for one of the cheaper ones, that adds another 50 cents. So yes, we can get $6.25.
Okay.
Kind of see the way I'm doing it? Rather than starting from scratch with each combination, which is hard to do, try to see the increments that you could go up.
Okay.
Okay, so a $7. Could we increase the original $5 by 7 to get it to 7? Could we increase it by $2?
Yes.
Yeah, we could get 2 of these drinks and 2 of those pizzas. And how about $7.25?
Yes.
Good. And that's, I'm quite sure, is the fastest way to do that.
Okay.
Because if you try to do it algebraically and lay out some equation, which is certainly an attempt, you could do 2a plus 2, we'll call them d, equals the total price. And now you try to figure out integer values of this. That could take all day if you start from fresh. In other words, if you try to figure out whether $5 works and then ignore that and then try to figure out whether $5.25 works, that's going to be a difficult problem.
Okay.
But if you start with the cheapest possible and try to work your way up as to various prices from there, I think that's the way that makes the most sense to do that problem. Which is what you kind of did. You started with the cheapest one possible. You immediately came up with $5 works. The trick is to use that information to calculate whether you can get the additional prices.
Okay.
And these are liable to be tough because they're the last 2. Normal distributions. How much do you know about statistics?
Not a lot.
Well, let me give you a quick primer on normal distribution. This is the mean.
Okay.
68% of the scores lie within 1 standard deviation of the mean. So, the mean score is 500, and it has a standard deviation of 100. So up to 600 and down to 400 What they're saying is that 68% of the scores lie in this interval right here, from 4 to 600. And there's an equal amount to this side and an equal amount to that side. So 32% lie outside of that interval. So it must be 16% over here, 16% over here, and 68% in the middle. You with me?
I think so.
That's Basic Statistics 101, and that's all you need to know for their questions about statistics. With that information, we should now be able to answer this question. So 10,200 students is equal to what percent, what decimal of the total students who took the test?
16%?
Be half of 68. It'd be that part right there. Notice that the mean was at 500. We know that 68% score between 400 and 600, which means 34% score between 400 and 500. So I can say that the number that score between 400 and 500 is 34% of the total students. So total students is equal to what? What is 10,200 divided by 0.34?
30,000.
And what percentage of the students score over 600?
16%.
Which answer then?
4,800.
Exactly. Now, that's probably all you have to know about statistics and normal distribution. It might be useful to know that 68% are within one standard deviation, which is that sign right there. 95% fall within two standard deviations. 99% fall within three standard deviations. So if the mean is 500, I know that 99% of the students are going to score between 200 and 800 because the standard deviation is 100.
I think I'm lost on this one.
All right. Well, that was statistics 102 kind of. But,
Okay.
well, not really. That really was part of the normal distribution statistics. But you probably, they give you everything you really need to know. They tell you that 68% of the scores lie within one standard deviation of the mean. Then they give you the mean, and they give you the standard deviation, so you can calculate everything else. Just make sure you recognize that that's what a normal distribution kind of looks like.
Okay.
Okay, and this is always the mean. And standard deviation might vary. With another type normal distribution, standard deviation might be 200, which means 68% of the students would score from 300 to 700. All right, let's go on. I recognize this problem. They had a problem similar to this in the
And of course, my first inclination is to say that if x plus y equals 10, then 1x plus 1 over y would equal 1/10. But
no, probably not. Well,
no.
let's take two numbers. 6 plus 4 equals 10,
Okay.
but 1/6 plus 1/4 does not equal 1/10.
Okay.
Okay? So if that was your inclination, try it before you go with that.
Okay.
Okay? What can I do? If I said add these two things, what would you do?
Common denominator.
What's the top look like?
Y plus x, or x plus y.
So what's the answer?
Oh, 1 over 20.
10 over 20.
Oh, 10 over.
Y plus x is 10.
Oh, yeah. Oh, geez. Okay.
Okay?
So 1/2.
Yeah. Okay. So again, we have a problem where we don't know what to do whatever you do know how to do. In other words, if we start with that, let's see what we can do with this. And the moment you take that first step, you've solved the problem. Okay. Let's see. Let me see where we got the first time on this first test. Looks like we got the 20 on 459, and then the second section, number 5. So let's go to that second section. It must be this one right here. Okay, according to my notes, we did number 5. So let's have a look at number 6.
Okay.
Let's see if there's any additional information above this.
Yeah, because it's going to say otherwise I don't think it can be determined.
Correct. They fool you by making it look like an isosceles triangle, and if it were an isosceles triangle, x would be equal to y, but they don't tell us it's an isosceles triangle. If it happens to be a triangle like this, then we don't know. In other words, in that case, this would be bigger, x would be bigger than y, but if it were oriented the other way, y would be bigger than x. The key thing to notice here is that you cannot assume that it is an isosceles triangle just because it looks like one.
Okay.
What's your first step going to be?
The first step is, it would be negative root 3 minus root 3 divided by root 2 minus negative root 2, so plus root 2.
Okay. It's important also to realize that line M is perpendicular to line L. So what does that say about the signs on their slopes?
It's going to be the opposite.
Okay, so we don't really need to know the slope. We just need to know the sign on the slope. What's the sign on the slope of L?
Is going to be negative, which means M will be positive.
So this is minus over plus. So this is the larger quantity. Okay? And I think the key here is not to get caught up in the fact that there's a bunch of radical signs. They have really nothing to do with anything. It's all about determining the sign on that slope, knowing that the sign on the other one is going to be the opposite.
I know, and I'm glad you pointed that out because I was getting ready to calculate them.
Well, you could certainly do that, and you'd have come up with the right answer, but probably taken...
Wasted a lot of time.
Yeah. I really have this one blown up big. Let me reduce the size of it a little bit. Well, they don't get tired of this one. We've seen this one 4 or 5 times.
Okay, well, A is going to equal 30. What I did is I added all the A's together and came up with 12 and divided by 360.
Okay. So what's the average angle in the circle?
Oh. You know what? I'm not doing good today either because I'm staring at this going, I have no idea.
Okay. What if I made this the problem? And I don't label anything.
Oh, well,
And I say, what's the average angle that you're looking at there?
360 divided by 5.
That's it.
Okay. Jeez. Yeah, I feel like I just had a brain freeze there.
It's okay. No, we covered this before, but it was when we were first working together, like 20 sessions ago. But they're trying to trick you by making you go through the math of figuring out A, but it doesn't really help to figure out A.
No, it doesn't make any difference at all.
Right. And just knowing that the measure of any 5 angles in a circle or some number of angles is going to be 360 divided by that number. I may have to go to the next page here to get the rest of this. Let's see here. Yeah. Okay, good. An average problem. What's the one word that applies to all average problems?
The total.
Okay, so let's start there.
So the first one would be 450. And then the second one would be 425.
How many tests is she going to have on the second one?
5.
So what was the lowest grade dropped?
25.
Right. Okay.
Okay, so the area is base times height, so we could have 1 times 40. So the
Okay.
answer definitely, that takes out A and B.
What's the shortest perimeter you could have? Based on what else we know. We know that the shortest perimeter is when it's a square, right?
Yes.
Okay. But if this were a square, then this would have to be square root of 40, which is not a very nice number. Let me think. We see that all of our answers end in zeros. So we know that it's not square root of 40 is one of the answers. All numbers must be integers. What is the formula for perimeter?
At all sides.
So it's 2b plus 2h. Well, I'm sitting here trying to think, is there an easy way to do this? We know that 2b plus 2h is the perimeter. And that's what they're asking about. So could we have a perimeter of 20? Well, probably not, because even though we're not going to use this as an answer, we know that the square gives us the smallest perimeter. The square would be a side of root 40. What is that? So approximately that is 6 and change. So what would the perimeter of this square be? That would be at least 12 plus 12, so it would be at least 24. So there's no way you could get a perimeter small as 20. So we can rule that one out.
Okay.
Could we get a perimeter of 40? And once we answer this question, I think we'll be able to answer all the others without doing all the math. Well, what produces an area of 40? Let's try 4 times 10, but that gives you a perimeter of 28. That doesn't work.
No, and 2 times 20 equals 40, will give us a 44 perimeter.
There's something going on here in the fact that we have a 2, a 4, another 2 and a 4, and another 2 and a 4. So if we can figure out whether these are possible, I think we can figure out whether these are possible just by logic. There's nothing that says that the dimensions have to be integers. In other words, it could be square root of 40 times square root of 40. The problem is that obviously when you have an irrational number here, you're never going to end up with a 0 in the perimeter.
Well, that's funny because I just noticed too that they say if the area of a rectangle is 40, which of the following could be the perimeter? And then it says indicate all such areas.
Oh, you're right. They should have said indicate
All such perimeters.
yes. Huge thing. Gosh, is that a trick or is that on purpose? Because if that's on purpose, 40 is the answer. Let me check the answer code here. Let's see. That was the test for the first one and the second one. No, it isn't. That's the test for the second test. Let me pull up the answer code for the first test. And this is section 5, number 11, B and D. 40 and 400.
Huh. That one just doesn't make sense.
Well, I understand it. I'm just not sure how to solve it. How do they know that 40 and 400 are going to be answers? I'm not sure. I hate it that this is going to be our last question that we do.
That's okay, though.
And I'd like to answer it, but I don't want to take up any more of your time and figure it out. I'll probably sit here and cogitate about it for about half an hour here, and if I finally figure it out, I may text you or something. I don't know.
Which would be fine, believe me.
Okay. Okay.
Okay. Well, I just want to thank you so much for all of your help, and I will let you know how I do on the test.
Well, thank you. I would appreciate that. I really would.
And if you ever need a reference, I'd be more than happy to be one for you.
Well, I might take you up on that. I use references at the back of my brochure and on my website or referrals, and so yeah, I might just do that.
Yeah, you've helped me immensely, and I really appreciate it.
Well, thank you very much, Angela. I wish you the best of luck and do good on your test.
Thank you.
Okay. Talk to you later.
Okay.
Bye-bye.
All right. Bye-bye.